Okay, I'm a senior lecturer, and so my job's split between teaching, research, and I think what they call service, which means administration, but also outreach. And my research is in radio astronomy.
For those of us like myself who aren't studying physics, could you explain what radio astronomy is?
Oh, certainly. Okay, radio astronomy uses big antennas which tend to have a sort of parabolic shape like the Parkes dish, which catch radio waves from space and focus them to a receiver. And that receiver is very much like your radio set. You can tune it to pick up different frequencies. And if you scan across the sky from this, you'll find in some places the radiation is very strong, in others it's not so strong, and you can make a map of the radio sky. So I do molecular line astrophysics combined with radio astronomy, although these days we push right up into the submillimetre, which is getting much closer to an infrared or even an optical regime. And so the idea is that there's molecules out there. The most common is the hydrogen molecule, H2. But at trace amounts, there are other things. For example, carbon monoxide is the next closest to the hydrogen molecule. And the good thing about carbon monoxide is it's very easy to observe with radio telescopes on Earth. It emits at, among other regions, 116 gigahertz. And because we know the frequency on Earth, if we can see what it's doing in space, we can see how all those molecules are moving and whether they're collapsing to form stars. And there's a heap of other molecules, and some of them are found in cold gas and some are found in warm gas. And so we can put, using these, we can put a really good picture of star formation together. And one of my other interests is the biomolecules, which is the sort of molecules that eventually might have given rise to life on Earth or possibly elsewhere in the universe.
How did you come to studying this?
Right. As with most women my age, almost none of us have had traditional pathways into physics. In my particular case, I didn't do physics at high school because at that stage I'd planned to do an arts degree in history and literature. But then I discovered I really liked science. But back then it wasn't that easy to get physics up at university. And so I actually went and started doing a degree in biology, decided I didn't like it, took a few years off. In my case, I had some children, which made the subsequent studying more complicated. And then later went on and decided to do a degree in maths and physics and see where it led. And then one thing led to another, and someone suggested, because I was doing quite well, that I should do a vacation scholarship over at CSIRO in radio astronomy. Then I met my PhD supervisor, and he suggested I do a PhD, so I did. And then I started teaching as well while I was doing a PhD, and ran a public access observatory out at the University of Western Sydney near Penrith. And then they needed someone to be the director of first year laboratories here, and quickly, and I was available for the gig, and so then I started here in beginning of 2001, and I've been here ever since. So it's been the longest job I've ever had in my life.
In terms of collaboration, how important do you think that is in your work, but in science as well?
Oh, it's incredibly important in science, and definitely in my work. These days, telescopes can't be afforded to be built by only one country. That's not the really big ones.
Yeah.
And so, for example, ELMA, the telescope in Chile, it's got 64 dishes, and it's the biggest astronomy project ever built to date.
Wow.
Yeah, it's pretty amazing actually. To get time on ELMA is really special, and the only way you can do that is to have a really biggish collaboration, lots of different skills, and you have to put up a really good science case. So it's got a 10 to 1 oversubscription rate, so for every 10 proposals only one gets time. Yeah.
So this is a little bit off topic, but outside of your work, do you have any other interests?
Oh, yes, reading. Reading,
Yeah.
cooking, bike riding and going for long walks. That's most of it. Learning languages, I enjoy learning languages.
Okay. Oh,
Yeah.
well, I guess if you get to travel a lot, that would probably
Yeah, so I've learned to speak a bit of German and some Spanish. I did French at school and my French is much better, so that's been good fun. Yeah, much less progress with the Japanese, but one day I'll get there.
Yeah. Do you find it hard to find that balance between exploring your other interests as well as your work and
yes.
family? Yeah.
Yeah, it is very difficult. The downside is that you don't get a lot of downtime. So you're working with people right around the world, and especially if there's observing proposals due, you kind of have to be checking your email at weird hours and working at night. On the other hand, the upside is if you've got children, it does mean you can spend a morning to go down to the school for whatever's needed there, and then of course the price you pay is you work after they go to sleep at night, but that kind of works well. But then also every now and then you get sabbatical and you go observing and things like that, and that's really, really nice. I'm looking forward to that. I've got 6 months just to do research.
Okay, so what sort of work do you do?
Well, I've got a few different research projects. The one that you've probably read about is the one on varying constants.
Yes.
Okay, so I've been working on that for a little while. So I'm interested in knowing whether the laws of nature are the same throughout the history of the universe and whether they are the same everywhere in the universe. So we always assume that that is the case. It's an assumption, actually. There's nothing in physics which requires it to be so, but there are a lot of things in physics which assume those things to be the case.
Right.
So, but it's worth testing those things. After all, the universe has changed dramatically over 14 billion years. 14 billion years ago it wasn't here, and today it is.
Yeah.
So it's worthwhile asking a question.
When you say constants, variation in the constants, what sort of constants?
Which
do you
particular
mean?
constants? Okay, so so these studies of this sort are always, when they're meaningful, restricted to dimensionless constants, because they're pure numbers, and you can actually measure those meaningfully in remote parts of the universe. You can't measure the speed of light in any known way in the distant universe in any easy way. So you tend to stick to the things that you can do. And so one of those, there are various dimensionless constants that you can measure. One is alpha, the fine structure constant, which is E squared over h bar c, which is the quantity in physics that you would have come across already, which relates to the strength of the electromagnetic force.
Okay.
Alright, okay.
And another one is the ratio of the electron to proton masses. So that's a dimensionless ratio, of course, and you can measure that.
What are some of the challenges you commonly come up with in your research and work here?
Money. Australia also doesn't have direct access to a large optical telescope which is good enough for the sort of research that I do. It's less of a problem because you can access data in other ways these days, but that's a minor complaint really. But if I wanted to do something specific in this field and get specific observations rather than using observations from an archive, then I'm in a less competitive situation compared to somebody in the States or in Europe, actually.
Have you been involved in the peer review process, and what are your thoughts on that?
Actually, yes. So I do peer review often.
Yeah.
I don't know how often. I try and minimise it. Sometimes I turn it down. Try not to turn it down. But if I really can't get it done, I turn it down. Yes. So I do peer review for quite a few journals.
Yes. Okay.
And fund granting bodies.
Right. Okay. Do you come across in the peer review process many people just abusing their position to, like, they're rejecting quite a few papers that are actually quite well founded, and that could
Not often. I've seen it, but not often.
No. Okay.
I think mostly people are honest and ethical, but not always competent.
No. Okay.
Have you submitted many papers yourself for peer review?
Yeah, I published a total of about 300 papers actually,
Wow.
but of which about half of those are strictly peer-reviewed papers. The other half are conference proceedings or popular articles.
Okay.
Oh my goodness.
Okay. Is there any advice you could give to, like, first years our age?
Do what you enjoy doing is the best thing, the best piece of advice. Because if you don't do what you enjoy doing, you might end up doing something badly as well as not enjoying it. Right? So. Whereas if you enjoy doing it, you'll probably be more successful at it. So that would be one, I think, really strong piece of advice. If you're really interested in something, you want to pursue it, even if it doesn't necessarily look like it's going to make you the wealthiest person in Sydney, don't worry about that. Do what you enjoy doing, because you'll be happier.
Yeah.
I mean, I really enjoy what I'm doing.
Yeah.
If I had the chance of going backwards and making different decisions, there'd be a few different decisions, but by and large, I would still end up a research scientist and probably in astrophysics. I mean, it's a